Welcome to Learn with us. This is the 8th lecture of Basic Electronics. First, we will have a quick review of our previous lecture. In your last lecture, you studied about piecewise linear model. You also studied about constant voltage drop model. In your previous lecture, you also understood what is an ideal diode model and what is a small signal diode model. Now, what are the learning objectives of this lecture? In this lecture, you will study about applications of diode, where you will understand how diode acts as a switch and how diodes are acting as logic gates. Now we will understand applications of diode. First, we will look at how diode acts as a switch. When the diode is acting as a switch, it can be in one of two states. The first state is a conducting state. In this state, this diode is forward biased, or we can say that the device is on. And the second state is non-conducting state. In this state, the diode is reverse biased, or we can say that the device is off. Now, look at this concept. If you have a condition like this is point A, and this is point B, and this is R, and the voltage at point A is 16 volts, and the voltage at point B is 20 volts, and you have to find VAB. So how you are going to find VAB? First you look at the direction of flow. If this is the direction of flow, then VAB will be VA minus VB is equal to 16 volt minus 20 volts is equal to minus 4 volts. Okay, if you have another condition like this is point A, this is point B, and this is the direction of flow, and this is R. Here VA is 20 volts and VB is 5 volts. Now in this case, VAB will be VA minus VB is equal to 20 volts minus 5 volts is equal to 15 volts. Now, if there is another condition like this is point A where voltage is VA, this is point B where voltage is VB, and this is VAB which is flowing in this direction. Now, for suppose if VA is unknown and VAB is 5 volts and VB is equal to 4 volts. So how you are going to find this VA? You just have to rearrange this equation for VA. So here VA will be VAB plus VB is equal to 5 volts plus 4 volts is equal to 9 volts. So this is how you are going to find voltages for conditions like this. Now look at this example. If you have a circuit like this, where this is source voltage of plus 5 volts, this resistor is of 2.5 kilo ohms, this is the direction of current, and this is unknown voltage V. Now what will be the values of this current and voltage for this circuit? Now first we assume that this diode is on. It means it is conducting or it is in forward biased condition, and we know that when diode is in forward biased condition, it is short circuit. It means the circuit will look like this for this assumption. Here this is the direction of current and this is unknown voltage V. We know that in case of conducting diode, the diode voltage is 0. It means here this unknown voltage V is 0 volts. Now for current, we will use KVL equation here. And now if you look at this circuit here and start from here and here, at this point V is 5 volts and at this point V is 0, and we know that R is 2.5 kilo. It means I is 2 milliamperes. It means in this assumption, current will flow, which will be the same for entire circuit due to series configuration. Now, what is our second assumption? Assumption 2. Assume that diode is off. It means it is non-conducting or reverse biased, and for reverse biased diode circuit is open. Now here is plus 5 volts, this is 2.5 kilo ohms, and this is ground, and this is current. Now when the diode is reverse biased, then we know that current is 0 and voltage is maximum. It means all this source voltage is given to this node V. It means V is equal to 5 volts, and here I is 0 milliamperes. It means in case of non-conducting diode, there would be no current flowing, and due to this, maximum voltage will appear at this node V. Now look at this example. If there is a circuit like this is diode 1, which is connected to a resistor of 10 kilo ohms, and here this source is minus 10 volts, and here is another diode which is connected to another resistor of 5 kilo ohms. This is plus 10 volts, this is D2, and here this B. Now if these diodes are acting as a switch, it means they can either be in conducting state or non-conducting state. So first we assume that both of these diodes are conducting. It means they are on or forward biased. It means they are short. So now in this case, this circuit will become something like this. This is D1, and we know that if diode is forward biased, then voltage is 0. This is the direction of I. This is 10 kilo ohms, and this is the direction of I1, which is flowing across this diode 1, and from here there is diode 2, which is also short, and here VD2 is also 0 because it is forward biased. Here resistor is 5 kilo ohms, this is plus 10 volts, and this is V. Now look at this point, we call this node A, and here current I2 is flowing across diode 2. So now if you look at node A, how many currents are entering this node and how many currents are leaving from this node? So we apply KCL at node A. As you can see, two currents are entering this node A, that is I1 plus I2, and one current is leaving from this node, which is I. So this is your equation number 1. Now how you are going to find this I? If we look at just this part of the circuit, we can draw this part separately like this. This is point A where VA will be the voltage. This is point B, and we know that point B voltage is minus 10 volts. Here current is flowing in this direction, and here resistor is of 10 kilo ohms. So how you are going to find I? You will apply KVL equation here, and here I will be VA minus VB divided by R. Now what is VA here? As you can see from this circuit, here VA is here, and since this node is in parallel combination, and we know that in parallel combination voltage remains same, so if here VD1 and VD2 they are 0, it means the voltage drop at this node A will also be 0. It means this VA is 0. Now after putting values in this equation, we will get something like this. This is 10 kilo ohms. After solving this, you will get 1 milliamperes. So I is 1 milliamperes. Now what will you do for I2? Now you look at this first half of this circuit, and you can draw this part like this. This is node A. This is plus 10 volts. This is 5 kilo ohms. Now at node A, voltage is VA, and we know that VA is 0. This is the direction of current I2. So now I2 will be 10 minus VA divided by R, that is 10 minus 0 divided by 5 kilo ohms, and this will give you 2 milliamperes. Now we know what is the value of I2, and we know what is the value of I, so we put these values in this equation 1 in order to find the value of I1. So now this equation 1 will become 1 milliampere is equal to I1 plus 2 milliampere, and if we rearrange this equation, we get I1 is equal to minus 1 milliampere. Now this negative sign indicates that our assumption is wrong. It means diode 1 is not conducting. It means it is not on. That's why this I1 is negative. Now what will be our second assumption? Now we assume that diode 1 is off and diode 2 is on. Now the circuit will become something like this, because we know that when diode is reverse biased, it is open circuit. Now here this is plus 10 volts, this is 5 kilo ohms, this point is V. Here this diode 2 is conducting, so here VD2 is 0. This is 10 kilo ohms. This is minus 10 volts. Here current I is flowing in this direction. Here current I2 is flowing in this direction. We know that in case of reverse bias diode, current is 0 and voltage is maximum. This is point A or node A. Now if we look at node A, Now what will be KCL equation now? As you can see here at node A, only one current is entering, which is I2, and one current is leaving, which is I. So this is your equation 1, because we know that I1 is 0 now. Now, how you are going to find I or I2? Now, we can remove this part of the circuit now, because here there is no current, and from this equation we know that I2 is equal to I. It means now I2 and I, they are in series, because we know that in series current remains same. So this circuit can be redrawn something like this. This is plus 10 volts, this is minus 10 volts, this is 5 kilo ohms, this is 10 kilo ohms, here there is V, and we know that I2 is flowing here and I is flowing here. It means now I2 is equal to I, as the circuit is in series configuration now. So how you're going to apply KVL here? Here KVL is applied this way. You start from this point and this is your ending point. So here there will be 10 minus 10 divided by 5k plus 10k is equal to 20 divided by 15k is equal to 1.33 milliamperes. This is the value of current. It means I is equal to I2 is equal to 1.33 milliamperes. This is the value of current for this circuit. How you are going to find voltage? We know that our final circuit looks something like this. This is plus 10 volts, this is minus 10 volts, this point is V, this is 5 kilo ohms, and this is 10 kilo ohms. Okay, and here in this direction current I is flowing. And if we look at this half of the circuit, it can be drawn something like this. This is point V, this is 10 volts, this is 5 kilo ohms, and we know that in this direction current I2 is flowing. So here we can write our KVL equation like this. I2 is equal to 10 minus V divided by 5k, or 10 minus V is equal to I2 multiplied by 5k, and here 10 minus 1.33 milliampere into 5k will be equal to V. After solving this, you will get V is equal to 3.35 volts. Okay, here we have taken first branch before this node V. We can also find the value of V by taking this second branch after this node V. Now in this case, this will be our circuit. This is V, this is minus 10 volts, this is 10 kilo ohms, and here current I is flowing. So in this case, KVL equation will be I is equal to V minus 10 divided by 10 kilo ohms or V plus 10 is equal to 1.33 milliampere into 10 kilo ohms. Therefore, V is equal to 13.3 minus 10 and V is equal to 3.3 volts. So this is the value of V when you take this second branch after node V. So this is how you are going to find I and V when you are considering that the diodes are acting as a switch. Now we will understand application of diodes as logic gates. Diodes with resistors can be used to implement digital logic functions. Now there are two binary digits. First is 0, which means low, off or false, and second is 1, which means high, on or true. It means in binary language only these two digits can be used. It means they can either be 0 or 1, and there is no other number used in binary language. Now there are different types of logic functions. First, we'll talk about logic OR function. In this function, output is true when any of the given inputs is true, but in case of logic AND function, output is true when all given inputs are true. Now we will understand logic OR function using diodes. Okay. This is diode 1, this is diode 2, and they are connected to resistor R. This is ground. This is input terminal A, this is input terminal B. Here voltage is VA, here voltage is VB. This is output terminal and we call this terminal Y. Now in case of logic gates, we draw truth tables. Here we have two input terminals and one output terminal. So how many input combinations are possible? Here we use this formula 2 raised to the power n, where n is number of input variables. Here n is 2, it means 2 raised to the power 2 is equal to 4. So in this case, there are 4 possible input combinations. In first case, both inputs are off. In second case, one input is on and one is off. In third case, input A is off and input B is on. And in fourth case, both inputs are on. So what will be the value of output in all these cases? First we'll look at case 1. Now we know that in this case both inputs are off. It means 0 volt is applied to terminal A and again 0 volt is applied to terminal B. We know that voltage drop at ground is 0 volts. This is R and here we have output. Now as you can see, this terminal A and this ground, they have same potential. Similarly, this terminal B and this ground, they have same potential. It means here current I1 is 0 and here current I2 is also 0. Why? Because current only flows when there is some potential difference, and we know that current flows from higher potential to lower potential. Since there is no potential difference in this case, it means there is no flow of current, so here output is 0. So here we write 0. Now we look at case 2. In this case, terminal A is on and terminal B is off. It means some potential is applied here. For suppose if this potential is plus 5 volts and here no potential is applied, so it is 0 volts. This is 0 volts, this is 5. Now as you can see, there we have higher potential and there is lower potential. It means here current I1 will be flowing from higher to lower potential in this direction, and since this terminal B and ground they have same potential, it means here I2 is 0. But since some current is flowing here in this circuit, it means there will be some output. So here value of Y is 1. Now look at case 3. In this case, terminal A is off, it means no voltage is applied to this terminal, whereas terminal B is on. For suppose plus 5 volts are applied here. So this is R, this is ground which is having drop of 0 volts, this is Y. Now in this case I1 is 0 because we know that terminal A and ground they have same potential, so no current will flow here. But when we look at terminal B, here current I2 will flow in this direction, that is from this higher potential to this lower potential. So here there will be some output, it means the value of Y is 1. Now look at case 4. In this case, both terminals, that is terminal A and B, they are on. It means potential is applied to both of these terminals. It means current I1 will be flowing in this direction and current I2 will be flowing in this direction. This is R and this is 0. So in this case, again, we'll have some output. So this is logic or function using diodes, in which there is no output only when all inputs are off. But even if only one input is on, we'll get some output, as you can see here. Now we will understand logic and function. If we have one diode like this and other diode like this is D1, this is terminal A, this is terminal B, this is D2. Here voltage is VA, here voltage is VB, and they are connected to resistor which is connected to voltage source VS. This is R, and here we have output which is Y. Here truth table is A, Y, and as there are two input variables, it means number of combinations will be 4. In first condition, both inputs are off. In second condition, input A is on and B is off. In third condition, input A is off and B is on, and in fourth condition, both inputs are on. Now we look at case 1. So what will be the value of Y in this case? Now we know that in this condition, terminal A is off. It means there is no voltage here, and terminal V is also off. Again, there is no voltage here. Now if we have a supply voltage of plus 5 volts, this is R and this is phi, that is output. Now we know that when positive voltage is applied to the positive terminal, that is anode of diode, then it becomes forward biased. It means it is in conducting mode. So now here this circuit is short. Now again for this diode, again it is in forward biased region. It means it is conducting. Now we know that when diode is on or in conducting state, voltage drop is 0. Here VD2 is also 0. It means this point is now maintained at 0 volts. It means here the value of Y is 0. So we write this value here. It means output is 0 when both diodes are off. Now we look at case 2. In this case, terminal A is on and terminal B is off. It means here voltage is plus 5 volts and here we have 0 volts. This is A and this is B. Now first look at terminal B. Again here this positive voltage is applied to this positive terminal of diode. It means now this diode is in forward biased condition. Here VD2 is 0. Okay, now this point is maintained at 0 volts. Now if we look at this diode, here as you can see there is no potential difference because this terminal A and this source voltage have same potential values. It means there is no current flowing here, and here this diode is in reverse biased condition. So it means this is open circuit now. Now as this point is now maintained at 0 volts, it means here the value of Y is 0. So we write 0 here in this table. Now look at case 3. In this case, terminal A is maintained at 0 volts. It means there is no voltage applied here and this terminal A is off, whereas here terminal B is on where 5 volt is applied here. source is plus 5 volts, this is R and this is Y. Now look at this diode 1. Here again this anode is connected to the positive terminal of this battery. It means this diode is conducting, it is in forward biased region, so this circuit is short. Here the value of voltage is 0. It means this point is maintained at 0 volts. Now look at this diode 2. Here as you can see the potential is 5 volts, which is similar to potential here. It means there is no potential difference. It means here I2 is 0 and this diode is in reverse biased region. It means it is open circuit now. Now since this point is maintained at 0 volts, it means here the value of output is 0. That is 0. Now look at case 4. In this case, both terminals are conducting or on. So what will be the value of output here? Here at terminal A we have 5 volts. At terminal B again we have 5 volts. Here source is 5 volts and here we have resistor R. Now in this case, as you can see, this Vs and this terminal A has same potential. There is no potential difference. It means here I1 is 0 and this diode is reverse biased. It means it is open circuit now. Again look at this terminal. Here the value is 5 volts, which is equal to this source voltage. Here again there is no potential difference. It means there is no current, that is I2 is 0, and again this diode is reverse biased, so this is open circuit now. Now we know that when the diode is reverse biased, all the voltage is given to the node. So here this point is maintained at 5 volt. It means here output is 1. So we write this value of y1 here in this table. It means that in case of logic and function, output is 1 only when all the inputs are on or 1, otherwise we get no output. So this is logic and function using diodes. Now look at this example. First we'll talk about logic or function. If you have a circuit like this is input A, this is input B, and this is input C, and they are connected to a resistor. This is ground. This is V out or output, which is represented by variable Y. Here voltage is VA, VB, and VC. As I have mentioned earlier that in case of logic or function, output is true even if only one input is true. So it is expressed as y is equal to A plus B plus C. Now, how we are going to find the output of this circuit? We'll draw a truth table. We know that there are three input variables: A, B and C, and this is Y, which is output variable. So how do you know that how many combinations of inputs will be here? We'll use this formula 2 raised to the power n, where n is number of input variables. Here this n is 3, it means it will be 2 raised to the power 3, which is 8. It means there will be 8 combinations of inputs here in this example. What will be the first combination? First, we assume that all the inputs are off, so the output is off. Now, if this input C is on, this is off, then output is on, because if you put these values in this equation, you get y is equal to 1. Similarly, if input B is on, A is off, C is off, then again output is on. If input A is on, B is off, C is off, then output is again on. If inputs C and B are on, A is off, then output is on. If inputs A and C are on, this is off, then output is on. And if inputs A and inputs B are on and C is off, then again output is on. And if all these inputs are on, again output is on. So this is logic OR function, which shows that output is off only when all the inputs are off, and this output is on when all or any one of the given inputs is on. Okay, so how many combinations will be there when there are 4 input diodes? Then there will be 2 raised to the power 4 is equal to 16 combinations. So this is logic OR function where diode is acting as a logic gate. Now look at this example. Here we'll talk about logic AND function. If you have a circuit like this is diode A, this is input diode B, and this is input diode C, and they are connected to a resistor which is connected to an input source. This is R. Here voltage is VA, VB, and here VC. And here is output voltage V out or Y. Now, in case of logic AND function, output is true only if all the input values are true. So it is expressed as Y is equal to A multiplied by B multiplied by C. Now, how you are going to find the output in this case? Again, you will draw a truth table, and we know that there are 3 input variables A, B, C, and this is output variable Y. So how you are going to find number of combinations? Again, we'll use this formula 2 raised to the power 3, which gives us 8. It means there will be 8 input combinations. What will be first input combination? In first input combination, all inputs will be off, so output will be off. If this input C is on, B is off, A is off, then again output is off, because if we put these values in this equation, we get Y is equal to 0. And if this input B is on, C is off, A is off, then again output is off. If input A is on, B is off, C is off, then output is off. If inputs B and C are on, this is off, then again output is off. If inputs A and C are on, B is off, then output is off. If inputs A and B are on, C is off, then output is off. And if all inputs are on, then output is on. It means in logic AND function, output is on only if all the inputs are on, and this output is off in any other input combination. So, how many combinations will be there in case of 4 input variables or diodes? There will be 2 raised to the power 4 is equal to 16 combinations. So this is logic AND function where diode is acting as a logic gate. That's all for today. Now, what are the key takeaways of this lecture? In this lecture, you studied about applications of diode. First, you understood how diode acts as a switch. Then, you understood logic or function using diodes. In this lecture, you also understood logic and function using diodes.
Thank you for watching this video. If you have any questions, then write your questions in comment section of this video. Don't forget to subscribe our channel and share it with your friends and family. Thank you.